So we'll do 128.0.0.0/2. Let me double check that again. 128.0.0.0/2 greater than or equal to 17. 128.0.0.0/2 greater than or equal to 17. Wow. If you struggled with this one, that's okay. That's okay. We'll get you through this. Is there a GE or LE? Yes or no? In this case, there is. So convert the slash subnet mask to a wildcard mask by subtracting from a mask of 255, 255, 255. Okay, so what is the subnet mask? A /2. What does that convert to? That's the first step here. What does that convert to? It's 192.0.0.0. That's what it is. If you struggled there, it's okay, but think about it. That's /2. We have 2 binary 1s. That's it for the network portion. 2 binary 1s in that subnet mask. Everything else is 0. So the 2 binary 1s would be the 128-bit position and then the 64-bit position. So 128 plus 64 is 192. Everything else is 0. So 255 minus 192 is what? $63. There's our wildcard mask. 63. 255, 255, 255. Our address is 128.0.0.0 that we see in the prefix list. The wildcard mask is 63.255.255.255. So 128 plus 63. Man, I'm going to take off my shoes for this one. All right, no. 191. Two 255, 255. So the starting IP address is 128. The ending IP address is 191.255.255.255. So we've got this range of addresses now. And the subnet mask has to be what? Greater than or equal to /17. To 17. All right. So we're permitting in this case what? Addresses from 128.0.0.0 all the way to 191.255.255.255 with a subnet mask from 17 to 32. Does this address range look familiar to you? Does this address range look familiar to you? Look at the very first octet, 128 to 191. 128 to 191. Those are Class B addresses for IPv4. Class B addresses. So we are defining a range of all Class B addresses that have been subnetted. That's right. Every Class B address that has been subnetted. Because our subnet mask range is 17 to 32. We're not including /16. /16 would be the classful address for the Class B addresses. Right? /16 would give us the classful address. Well, in this case, we're saying, no, it's everything from 17 and onwards for the subnet mask. So all Class B addresses that have been subnetted. Let's look back at that so we can understand that. The range is from 128.0.0.0 through 191.255.255.255 with a subnet mask greater than or equal to 17. So all Class B addresses that have been subnetted. Not obvious at first, is it? Not at all. But yeah, that's what it does. It's definitely one of the harder ones we see on the page. Let's look at example number 3 in this case. And it should be very familiar to us. You know, it looks very close to example number 1, doesn't it? But there's a difference, and that difference lies within the less than or equal to versus greater than or equal to operator. Here it's less than or equal to. Let's not go to the chart, because we've seen this one. You should already remember from other examples we had that this is permit any route. Any route at all. That's what this means. Why? Because the range is 0, 0, 0, 0 through 255, 255, 255, 255. And then the subnet mask is going to be less than or equal to 32. So it could be anything from 0 all the way to 32. Example number 4 states we are going to permit 0, 0, 0, 0 slash 0. Do you see a less than or equal to or greater than or equal to operator? No, I don't. So what do? Let's look back at our flow chart. Our flow chart says if there is no GE or LE, look for an exact match of the subnet and subnet mask. So in this example here, we are looking specifically for 0, 0, 0, 0 slash 0, which is what? It's our default route. Our default route. Example number 5. We haven't seen this yet. So we're going to go out to our flowchart and do it. I see 0, 0, 0, 0 slash 1 less than or equal to 24. Wow. Seems complicated. Just like example 2 was complicated. Yeah, and it is. But once you see this detailed and outlined in the flow chart, it's not so hard to read.